Welcome to The Explainer. I am so thrilled you're joining us today because we are diving into something absolutely fascinating. We use it every single day, literally all the time, mostly without even realizing it. But language is not just some random bucket of words. It's actually this incredibly structured, scientifically observable, and totally invisible architecture that every single one of us shares. So today, let's put on our scientist hats and map out the blueprint of this hidden, rule-governed system that your brain uses completely effortlessly. Here is our roadmap for the journey. First, what is linguistics? Second, sounds, words, and sentences. Third, meaning beyond the dictionary. Fourth, the biology of language. And fifth, language in society. Let's get right into it. Section 1, what is linguistics? Okay, consider a highly relatable phrase. I ain't got none. Now, a traditional grammar teacher might instantly grab their red pen, cross it out, and call it wrong, right? They're acting as what we call prescriptive, telling you how you supposedly should speak. But here's the thing. Linguistics is not the grammar police. It's descriptive. When a linguist hears I ain't got none, they don't judge it. They observe a perfectly normal, highly rule-governed feature of a specific dialect. The goal isn't to say what's right or wrong. It's just to map and describe language exactly as native speakers actually use it in the real world. This brings us to a massive breakthrough by Ferdinand de Saussure. He basically split language into two distinct concepts. First, you have langue, which is the invisible, abstract system of mental rules that we all share in our heads. Then you have parole, which is the physical manifestation, the actual literal words coming out of our mouths in everyday life. Linguists are completely obsessed with langue. They want to decode those unconscious mental rules that your brain is applying right this very second to instantly understand what I'm saying. Pretty wild, right? Moving on to Section 2, sounds, words, and sentences. It all starts at the absolute micro level, sounds. Phonetics looks at how we physically produce sound. Try saying the word pat and then say bat. Notice how both of those start by pressing your lips together? But the p in pat is what we call voiceless. Your vocal cords don't vibrate at all. The b in bat, though, is voiced. Your vocal cords do vibrate. That tiny, microscopic physical change in your throat gets categorized by your brain in a process called phonology. And that tiny shift completely changes the fundamental meaning of the word in your mind. And the really crucial point here is that phonology is super active. Your brain relies on phonological rules that automatically change sounds based on their neighbors. Think about English plurals. In cats, the plural sounds like an S. But in dogs, it sounds like a Z. And in horses, it sounds like is. You don't pause mid-sentence to consciously calculate that, do you? No way. Your brain applies this rule-driven mental process on the fly, instantly picking the exact right sound category every single time. So once we have our sounds, we start building words. This brings us to morphology. Words actually aren't the smallest units of meaning. They're built from even smaller, foundational pieces called morphemes. It's kind of like a giant set of Lego bricks. Let's break down a word like unbreakable. We have the free morpheme, break, which can stand entirely on its own. Then we effortlessly snap on bound morphemes, un, which means not, and able, meaning can be done. Our mental dictionary snaps these roots and rules together to generate just an endless stream of vocabulary. And from those words, we build sentences. This takes us straight into syntax, and specifically Noam Chomsky's theory of generative grammar. Sentences aren't just flat, linear strings of words. They possess a hidden hierarchical structure. The cat chased the mouse breaks down cleanly into a noun phrase and a verb phrase. And this underlying structure brilliantly explains why ambiguity happens. Take the sentence, I saw the man with the telescope. Wait, did you use a telescope to see the man? Or did the man you saw possess a telescope? The invisible structure your brain subconsciously assigns to that sentence is what ultimately determines its meaning. Now, the absolute superpower of syntax is something called recursion. It's basically the ability to nest sentences entirely inside of other sentences. For instance, the cat that the dog that the boy owned chased ran away. We leverage a very limited set of rules to create an infinite number of sentences. Recursion is exactly what gives human language its unlimited creative potential. Which leads us to Section 3, meaning beyond the dictionary. Semantics is the study of literal meaning, showing us how words are connected in this carefully categorized mental web. We've got synonymy for words with shared meanings like big and large, antinomy for opposites like hot and cold, hyponymy, where a rose is a specific type of flower, and homonymy, for identical words that mean totally different things, like a riverbank versus a financial bank. Your brain navigates this incredibly complex web in a fraction of a millisecond to establish the exact truth of the sentences you hear. But literal meaning? That's really just the starting point. This brings us to pragmatics and the number 4. Philosopher Paul Grice suggested that in every single conversation, we follow an unspoken social contract governed by 4 maxims of cooperation: quantity, quality, relation, and manner. Basically, we expect people to say just enough, tell the truth, be relevant, and be clear. But what happens when we purposely break one of Grice's rules? Imagine you say, "It's cold in here," to a friend sitting right next to an open window. You aren't giving them a meteorological update, right? You're creating a passive-aggressive implicature. Your friend immediately infers that you're actually asking them to shut the window. As speech act theory teaches us, we are actively taking physical action with our words, rather than just politely exchanging facts. When we chain a bunch of these interactions together, we move into discourse analysis. The critical distinction here is between cohesion and coherence. Cohesion refers to the surface-level grammatical links, like using the pronoun he to refer back to John so you don't keep saying his name. But coherence, that's the deeper logical root system that makes a conversation actually feel like it makes sense. Real-world conversation relies heavily on both. It's a highly structured, collaborative activity governed by strict turn-taking rules and paired actions. Section 4. The biology of language. So where does all this invisible architecture actually live? The driving theory is modularity, the idea that language has its own dedicated physical real estate in the human brain. Scientists began mapping this out by studying aphasia patients. Back in 1861, Paul Broca discovered that damage to a specific frontal lobe area ruins speech production. A bit later, in 1874, Carl Wernicke found that damage to a totally different area ruins speech understanding. Today, modern neuroimaging shows us a dual-stream model, with distinct pathways specifically tasked with connecting sounds to meaning and sounds to speech. Language is deeply physically rooted right in our biology. And because it's biological, we see the most fascinating things during childhood development. When a little kid says, "I good" to school or "I ran away," those aren't just adorable mistakes. They are actually scientific gold. Chomsky's innateness hypothesis argues that children have a biological blueprint for language, a universal grammar. When a kid says, "I good," they aren't just blindly copying an adult. They are actively applying the universal past tense rule of adding ed. They're proving that language acquisition is an active, innate, biological process. That's exactly why every single child progresses through the exact same predictable stages. They act as these brilliant little linguists. They go from cooing and babbling in their first year, straight into the one-word stage, then two-word telegraphic speech, and finally bursting into full, complex sentences. Children effortlessly use their biological blueprint to solve the incredibly complex puzzle of their native grammar without any formal teaching at all. It is literally a marvel of human development. Finally, Section 5, Language in Society. Sociolinguistics reveals that language variation isn't just random, it's systematically tied to social power and identity. Back in 1966, William Labo famously proved this in New York City department stores. He documented that pronouncing the R sound was directly linked to a person's social class and the prestige of the store they were in. Our language shifts constantly. We use different dialects based on our region. We change our register based on how formal the situation is. And bilingual speakers often engage in code switching, seamlessly changing languages mid-sentence to express deep group identity and solidarity. This practical application brings us to Michael Holliday's systemic functional grammar. Essentially, every time you speak, you are subconsciously spinning 3 dials. The field, what are you talking about? The tenor, who are you talking to? And the mode, is it written or spoken? For education, this entirely shifts the goalposts from rigid correctness to dynamic appropriateness, giving people the exact right language tools for the specific real-world room they find themselves in. And that brings us to the end of our structural tour. We have zoomed all the way from the microscopic vibration of your vocal cords to the broad social forces that shape our identity. So I want to leave you with this provocative question to ponder today. How are the invisible language choices you make shaping your world right now? Next time you have a simple everyday conversation, I really challenge you to listen closely. You just might hear the invisible architecture at work. Thanks so much for joining me on this explainer, and keep learning.